All right, welcome everybody. It's Monday, April 27th, BPeriod stats. Mr. Doctor, if you would turn your camera on, otherwise I can't keep you in the room.
My camera's on.
Thank you. Here's the plan for today and the week. Most everybody submitted that problem set number 2 from 6-5 sometime over the weekend. I'm missing a couple of your alls, and I've graded them and put them in blackboard if I had them over the weekend. If you came in this morning, I probably haven't looked at it yet. So I'm going to go over, and if I recall, I did problem set 1 or number 1 in the class, and I started 2. So it's just 2 through 5 or 2 through 6. So I'm going to run through those problems, and that'll prep you for the quiz. The quiz I just loaded up on Blackboard, so it's there. And my request of you is to take the quiz. It's let's see, it's about 6 questions, almost identical to what we're going to do here today in the problem set that you did from when we were together last Wednesday. Take the quiz, and if you could put it back in my Dropbox today would be great, but no later than 3 o'clock tomorrow, so that I can grade them, and then on Wednesday we can go over it. And then you'll have 2 quizzes for this chapter. You have a quiz that we took weeks and weeks ago on 6-1 through 6-3, and then this quiz, so that'll be your kind of prep. And then on Wednesday I'll give you the quiz back, go over it, do a little review on 6-1 through 6-3, and then for the 5-day gap from Wednesday to next Monday, I'm going to give you the chapter 6 test.
They're lit.
That's the plan. Yes, sir.
Aiden says he's waiting in the lounge.
I think that was Malik. Unfortunately, I came through real garbled and real faint.
Aiden is waiting in the lounge. He's been there for like 10 minutes.
Yeah, I've let him in like 3 times, and it says it's pending. Let me go back and see. It keeps saying he's joining. If you can text him, just tell him to come out and then come back in. For some reason, he's kind of got lost in the loop. Not sure exactly why, but
You said we got a quiz tomorrow?
It says he's joining. So if you can just text him or however you're communicating with him, tell him to cancel out what he did and then try it again, because I've clicked on him to join at least 3 or 4 times. All right. So questions on what the game plan is?
Yeah. When do we have our quiz? You said
It's in Blackboard right now. If you can take it today, that would be outstanding.
How long have we had it in for?
20 minutes.
10 minutes?
I just put it in a few minutes ago.
Is it with something we already know?
I hope so.
You hope so.
Yeah. Well, we're going to go over the problem set that I gave you last Wednesday right now. And if you understand that, you should be in super duper shape. All right. Okay. Mr. Cord, did you make it in?
Yes, sir.
Okay. Yeah, I clicked on you to join like 3 or 4 times, and for some reason it kind of got lost in the
Sauce. It happens.
you were in the spin cycle. Okay.
Mm-hmm.
Just real quickly to reiterate, we're going to go over that problem set that you guys got last Wednesday. I've got them on the board, and I'm going to walk you through them. And the quiz on 6-4, 6-5 is in Blackboard. I asked that if you can take it today, that's great. Actually, if I was sitting where you're sitting, I would take it right after class if I could. It shouldn't take you but 30 minutes at max. And that way the information will be fresh in your mind, okay? And it should go pretty quickly. I'm going to run all 4 of these. I'm going to do problems 2 through 6. And you can see I've got them on the board, or you will see that I use the exact same format or recipe to solve these, okay? So it's fairly repetitive and fairly routine. So I think in the next, maybe not even take the whole class. So if we get done early, I'll let you go and start on the quiz right now. All right, right then. A couple things to keep in mind on the quiz. All of these are normal approximations, all right? And remember we're taking binomials, that stuff we did back where we had the n over x and the parentheses times however many trials times p to the p power times however many failures times the q power, all that stuff. And we're wedging those things into a standard normal curve. One of the key points to keep in mind, and you'll have a couple of these, is that to do that, they have to pass that test. And that's the n times p and n times q both have to be greater than or equal to 5. So just know that. N times p and n times q both have to be greater than or equal to 5. So that's the test. And n times p also gives you what? Gives you something very valuable.
Mean.
Mean, okay? All right, so if there are any questions before, I did number 1 in class for you, so I'm not gonna even talk about that one. I'm gonna run down, do 2 through 6 in fairly rapid succession unless I hear you ask a question or say stop, or let's go over this again. And like I said, I've got them all kind of semi-staged on the board, ready to go. I was trying to do them with my mouse, but the writing is so squiggly that it's not very beneficial. And I've been trying to get a stylus and a pad to do it. Actually, I'm shut and share my screen, but so far the school is I haven't had any success getting one of those. All right, are we ready to go? Okay. The other thing you're going to need for your quiz is this thing that we've been using for many weeks. So hopefully you've got one of these, which is the standard normal probabilities. If you don't have one of these, you can just Google it and download one and print it out, or use it on your screen. Or if you've got your textbook handy, it's table 3 in the back, in the index of your notebook, table 3. And it's the exact same values and numbers, it's just formatted slightly different. All right, any questions before we get going here? All right, let me know if you can see this. If you can't see this, I can improvise and change things up. All right, and number 2, so I back up a little bit. You got to know n times p and n times q both have to be greater than or equal to 5 to put a binomial into a standard normal curve. Key point. All right. The other thing is you have to keep in mind that continuity factor, and I'm going to stress that in the 4 problems so you don't forget. Otherwise, you're going to get a slightly different value. That's that 0.5, and I'll stress and explain that when I go over it. So number 2, if you've got your sheet in front of you, the probability was x is less than or equal to 8, n equaled 14, p equaled 0.4. I'll come in a little closer so it's a little bit larger for you. Let me know if I slip up on the screen. All right, so we got to calculate the mean, which is always n times p, right? Which Mr. Core told you. So in this case, it's the 14 times the 0.4, which is 5.6. All right, we're going to assume that n times p and n times q on all these. I'm not going to give you one where it doesn't already meet the test. And you know it does because n times p is 5.6. N times q is 14 minus 5.6, which is what, 8.4, something like that. So I don't even need to go any further. All right. Now I got to calculate the standard deviation, which is n times p, which we got right here, times q, which in this case is 0.6, because q is 1 minus p, times 0.6, and then take the square root. And in this case, it was 1.83. All right, everybody good so far? All right, I always encourage you to draw a picture, because then it makes it, you can visualize what you're being asked to calculate algebraically. So the mean was 5.6. It's asking you less than or equal to 8. So we're going back to the left, less than, just like in a number line. Now, I remember one of the little quirks to binomial approximation is that continuity factor. So we're not going to actually use 8. We're going to use 8.5. you always go opposite the direction it's asking you to solve for. You always go opposite the direction it's asking you to solve for. Just like in number 1, if it asked for the probability of x equals 8, we actually would have used 7.5 and 8.5 because it's almost immeasurable, the area under the line, and this probability in this area under the curve or under the line or behind the line, area and the probability are one and the same, right? And it's been that way all along for standard normal curves. So remember the continuity factor, go opposite the direction it's asking you to solve for. So it's going left. If I went 7.5, I'd lose 0.5 of an area here. So you know that's not correct. So let's go opposite direction. If it had asked for greater than or equal to 8, I would have used 7.5. Does that make sense? Somewhere scratch on here, continuity factor 0.5, just to remind you, because that's one of the areas to slip up. Okay, so I've got everything I need to calculate the z-score, because I need the z-score for 8.5. So it's 8.5 minus the mean, which we said was 5.6, over the standard deviation 1.83. And if we did all that math, we came out to 1.58. That's my z-score. Double check. And then we're going to go to 1.58 on here, which is 0.9429. And that's the area we got shaded here. That's it. You're done. Are we good? Good. All right. I'm going to do.
Wait, so 8.5 is just x is 8, so it just goes to 8.5.
Yeah, that's that continuity factor. So I just went to the right. I went opposite the direction that you're being asked to calculate. It'll make sense. I'm going to stress it again in these next couple. By the time on the third one, hopefully it makes sense. Any other questions on that number 2? All right, number 3. Let me know if you can't see it. Let's see. All right, number 3, what was the deal? It was melanoma, all right? Form of skin cancer, which I have a close, intimate relationship with. Let's see here. All right, our P is 98%. That's our P. So we're going to convert that to a probability to 0.98, right? So you had to kind of do a little interpolation there. So it's 0.98. Our N is 250. Let me do a little something here, a little better view of this. Let me know if it slips out of screen. Our N is 250, all right? So the mean, again, this is the exact same recipe all the way down the line. So the mean is N times P, which in this case came out to be 245. All right? And the standard deviation, that's N times P, so we multiply 245 times Q, which is 0.02, and we take the square root, and we come up with 2.21. Everybody good so far? All right. Then the question is, what's the probability that 240 or more of a group of 250 patients survive melanoma? All right, so our mean is 245. It's asking 240. So it's asking this area. All right, so we're going to the right. So that continuity factor, a little bit, see a little better. That continuity factor is 239.5. See, we went opposite the direction you've been asked to calculate. All right, don't forget that. Write it. I'd write it on. Remember 0.5 continuity factor. Write it on your table. All right, so we've got everything we need. Same deal. All right, so we're going to use what? X is 239.5 minus the mean of 245 over the standard deviation of 2.21. And we get a z-score of, it's going to be a negative value, and we get, what we get? Negative 2.49. Now we're going to go to the table and find out the value of negative 2.5, 249, that makes sense. So we're almost 2.5 deviations to the left of the mean. You know it's always going to be a negative deviation over on this left side. And the value of negative 2.49 is 0.0064, which is actually this unshaded area, which I don't really, is not what I'm being asked to solve for. It's asking for this. So we're just going to subtract that from 1, and we came up with 0.9936. Questions? Now, if you wanted, I haven't really stressed this, but if you wanted to cut corners and cheat a little bit, if you want, as long as you understand it, all right? If you look up the area for the positive of this, all right, the inverse, all right, the positive version of this, you're going to find 0.9936. All right, because of the symmetry of the standard normal curve, you could actually take the positive of this, and it's this 0.9936, which is this shaded area right here. All right, questions? All right, we're going to keep rolling. All right, number 4. Flip my page here, what we're talking about here. Pure Internet, 62% of employed adults use the internet or email on their jobs. That's this is probably old data. It's probably up like 99.9% now. All right, so our P is 0.62. Our N equals 250. Our mean is 250 times 0.62, which came out to be 155. All right. Our standard deviation is this times Q, which in this case is 0.38 under the radical, and that came out to be 7.67. All right. Again, you can see I'm doing the exact same way, same format. And the question was, what is the probability that more than 180 out of 250 employees use the internet or email on their job? All right. So let's see. So we got 155 for the mean, which we got right there. It's asking for more than 180, which I shaded here. That continuity factor is 179.5, because we're going to go opposite the direction of what you're being asked to solve. And now I got everything I need. So it's going to be the 179.5 minus the 155 over 7.67. And we do the math, and we came up with 3.19. Where's the score? Let me just double check. All right, we go to 3.1 on our table, we get 0.9983. But that's this area here, which you're not being asked to solve. You're asked for the other side, so we're just going to subtract that from 1, and we come up with 0.0012. That's for percent of probability. So there's my answer. Now, like I said, if you wanted to kind of cut corners and not do this, not that that's a big deal. If you look up at negative 3.19, you're going to get that value. Don't get the two kind of methodologies where you're coming in from the left side or the right side confused. Where you take a little bit of both, you're going to, I was reluctant to tell you that because I don't want to confuse things, but that's an option you have available to you.
How did you get the 179.5?
Because it asked you for, let's see here. It asked you for what's the probability that more than 180, more than 180. So it was asking you this side. That's that continuity factor, that 0.5 continuity factor. So we go opposite of the direction you're being asked to solve. Because if I went this direction, I'd lose between 180 and 180.5. Other questions? All right, let's see, that was 4. Let's see, I'll try to get this in here for you. All right, number 5. 5 and 6, we kind of use the same data. All right, 5, let me just refresh my memory. Federal Highway Administration, 2009 stats of the drivers in the United States, 50.2% are females, all right? The random sample of 50 drivers are to be selected for a survey. What's the probability that no more than half, which is 25 of half of 50 is 25. The drivers are female. So it's almost asking what the mean is. So we know it's going to be real close to the mean. All right. So we're going to figure out what the mean is. So our P is, be careful on this one, is 50.2%, which in probability equates to 0.502. 0.502. Let me just come up this to here, back this to here. Let's see. Make sure I don't lose you. All right, our N is 50. So this times this is going to give us our mean, which we know is going to be real close to half of 50, is 25.1. All right, our standard deviation is this times 1 minus 0.502, which, and then take the square root, and that's going to come up to standard deviation of 3.53. All right, it's asking you for what's the probability, if a random are selected, what's the probability that no more than half, which is 25. Oops, that's on the wrong side of the curve, right? 25 would be over here. Fix that. Be on the other side because that's smaller. Let's change this. Let's make that 25. Our mean is 25.1. I hate these numbers are so close. All right. All right. So it's asked to the left. Okay. So we're going left. So our continuity factor, we're actually going to use 25.5. Make sure you remember that 0.5 continuity factor. You good? So our z-score, sure I'm on the board here. So it's going to be 25.5 minus the mean of 25.1 over the standard deviation of 3.53. It's going to give me a z-score of 0.113, right? We knew it was going to be real close to 0 because I'm real close to the mean of 25. So we don't even need that 0.3 because our z-scores only go to hundreds. So it's 0.11. If I go to 0.11 on my table, I get 0.5438. Does it ask for percentage? Probability. So it's 0.5438, all right? Which makes sense because I'm just slightly above the mean. The mean is going to be 0.50000, right? So that makes a real sensical, that answer does make sense. All right. Questions?
This can all be done in your calculator, right?
Up to, let's see. Yeah, and
Yes.
this you're going to pull off the table. Off your table here. Everybody's got one of these, right? If not, it's table 3 in your textbook in the appendix or in the index, or if you just type in the standard normal probabilities table, there's several different versions that has the same information but formatted slightly differently that are out there. I mean, I got this off the internet. I like this one the best, just the way it was formatted. I thought it was more user-friendly.
What's it called on the internet?
Standard normal probabilities table.
Oh.
Standard normal probabilities table. All right, so we got, let's see, what was that? That was number 5. Now, number 6 is utilizing the same scenario, slightly different question. All right, same scenario with drivers. Number 6, it says, what's the probability that at least 3/4, excuse me, 3/4 of the drivers are female? So let's just, I didn't do a visual here, so let's do a visual. So we know it's, our mean is 25.1, right? And 3/4 is, we said was 38. Put that way over here. And it's at least 3/4. Are we going left or right? At least 3/4. So that would be on the left side, right? So that'd be all this stuff, right? You good? So here we go. I've already got what I need. So now instead of using 38, we're going left. I got to go up to 38.5, right? So my X is 38.5 minus my mean of 25.1 over my standard deviation of 3.53. Sure I did that right? At least 3/4 of the drivers are female. I'm just make sure I'm reading that right. Yeah. So we are going to use 38.5 minus 25.1. I actually did it wrong. I had 37.5. So anybody got a calculator handy real quick? What's 38.5 minus 25.1? Anybody? I can grab mine real quick. Hold
Say it
on.
again. What is it?
38.5 minus
That's 13.
25.1.
I got 13.1.
All right, divide that by 3.53, the standard deviation. Thank you.
3.796.
Ooh, that's off the charts. 3.79, so that's 3.8, which we don't even have on here. All right, so that's a crappy problem. Wrong. 38, at least 3/4, at least 3/4, at least 3/4. Yeah, because our table only goes to 3.4, so that's not even a great question. All right, so sorry about that. Moral of the story, I got to change. Maybe I messed up the wording on that. But on all these, you see, we want to know what N and P are. All right, just on any one of these, we multiply N times P and we get the mean. All right, we multiply the mean times the Q, which is 1 minus P, and we take the square root. Now we got the standard deviation. All right, I'd encourage you to draw a picture of what you're being asked. Remember the continuity factor of that 0.5, left or right, right? Or the opposite direction of what you're being asked to solve. Calculate the z-score. It's going to give you a probability. If it's asking you something to the left of the curve, you take it right off the table. If it's asking you something to the right of the curve, subtract it from 1. If like in that number 1 problem that we did last Wednesday, if it asks you, if say, let's go back here to this number 2. If it would ask you for x equals 8, as opposed to less than or greater than, all right? If it asks you for x equals 8, all right? In terms of that's all area underneath the curve, you're going to have to use, to get a measurable area, you're going to use 7.5 to 8.5. And you're going to have to calculate 2 z-scores. So we got z equals 8.5 minus 5.6 over 1.83, and z equals 7.5 minus 5.6 over 1.83. And you're going to get 2 z-scores, right? And we already did the 8.51, which happened to be, I shouldn't have erased it, was 1.58, which equals 0.9429 on the table, all right? Then you'd have to get a z-score here and a value. And the reason I put the 8, the larger number on the top, the larger x on the top, and the smaller, then you're going to subtract the smaller area from the larger area, and that's going to give you this area on the curve. If it asks you for, if it's like x equals something, because x equals something is just a straight vertical line up and down. And to get a measurable area and to use that continuity factor, go 1.5 left and right. All right. That is everything you need to know. N times P and N times Q both have to be greater than or equal to 5. And then follow the recipe. Multiply N times P and get the mean. Multiply the mean times Q and take the square root and get the standard deviation. Draw yourself a nice little visual of what you're being asked. Calculate the z-score. And then if it's anything to the left, you take it right off the table and you're done. If it's to the right, you got to subtract from 1. If it's between 2 values, subtract the larger z-score and the larger area from the smaller z-score and smaller area. That's it. You know that, you're in fine shape. Questions? Anybody? That's all I got. The favor I ask of you is if you can do it today, that's great, because I can grade some of them tonight, but you got to have it into me by 3 o'clock tomorrow so I can grade them, because I want to give them back to you and go over it on Wednesday, and then after Wednesday's class or sometime on Wednesday, I'm going to put a chapter 6 test in there, which is going to come from this quiz, and then you've got a 6-1, 6-3 quiz somewhere, hopefully on your desk there or in your notebook. And you'll have, and that one I'd like to get back by Friday evening. That way I can grade it over the weekend. And then we'll start chapter 7 next week. And unless you got any questions, I can maybe cut you loose a few minutes early and do the quiz now, or I'll be glad to hang around and answer any questions.
Good. Thanks, sir.
Okay, anything I can clear up for anybody? All right, so knock out the quiz in Dropbox. It's already there. Hopefully it's sitting there waiting for you if I didn't mess up. And otherwise, I'll see you on Wednesday. If you run into a snag, shoot me an email. It's not here. I can't find it. You got a question? I got office hours 2 to 2:30 every day. All right.
Sounds good. All right. Bye, sir.
All right. Everybody have a good couple days. I'll see you on Wednesday, if not before.
You too.
Take care.